Hello everyone, this is Sanaula. This demonstration is created on Windows OS and the same procedure is also applicable on the other operating systems such as Mac or Linux OS. This demonstration is based on RAVSim version v2.0 and the version v1.0 demonstration is also available on our YouTube channel. You can find the link below the description of this video. Once you downloaded the RAVSim, you will find this folder RAVSim v2.0. This folder contains all the necessary files and libraries that are required to run this simulator. Let's start by double-clicking the RAVSim icon. It will take a couple of seconds to run. Here we are on the welcome page of the simulator. RAVSim v1.0, a runtime simulator, was specifically designed for early-stage researchers and students, but RAVSim v2.0 is also very important for developers as well. As you can see, RAVSim offers a few options, including a runtime interaction VI, a dataset preprocessing, the classification, task analysis, and training. And you can also generate weights of the trained model, which you can use for further analysis. Finally, a neuromodel comparisons. A neuromodel comparison is quite important, as SNN is based on different neuromodels, which use differential equations. Each model is good for some specific task. So it is quite difficult to know which model is good for your task, right? So RAVSim is a standalone simulator that allows you to interact with these neuromodels and learn the balancing between these models' parametric values all at runtime environment. So let's start from the runtime VI. At the start, you will see a pop-up window. This window consists of the parametric value, a set of parametric value which required to run the neural model. So you can go with this default or you can update with your own parametric values. You can also go update the parametric value later stage at the runtime. So I will go with the default one and I will show you how you can update at the runtime. Let's start run spike. So here you can see a threshold value. You can play a threshold value. Let's say we will decrease to 0.6. As you can see, the interaction at runtime, a neuron communication is quite faster, right? You can decrease the reset potential and you can see that how it is affecting. The same way you can increase the tau also. You can see that how the neuron communications is quite delay. On the right side, one neuron is communicating neuron 2 and how they are communicating on the left plot you can see. And these parametric values play a critical role for the communication between neurons. In the spike detection, by using the input current, you can see a digital plot to see how the neurons are communication, when the neurons are turn on and when they turn off and so on. You can also generate a mixed signal plot. You can capture this mixed signal plot for your further analysis. You can either go back to the continuous simulation. You can create a VTA network. A VTA network which allow you to see that three different connectivity scheme, like neuron 1, this one is fully connected network. So neuron 1 all is connected with the neuron 2. And the same way you can see source equal to target, which means the neuron 1 is only connecting with the neuron 2 of I of j. And the same way neuron I of j is not connected only with the neuron 2 of I of j, but except that it is connected to all other neurons. Let's say you can also capture the graph and you can close it. So that's the runtime simulator. You can also increase and decrease the processing speed, simulation speed, and so on. Okay, we can go with the dataset pre-processing. So for the dataset pre-processing, if you are creating a custom dataset for your specific classification task, so either you have images or you can download the images from the internet and so on, but you need a pre-processing, a different size, a different number of pixels which are required to feed before into the model before the training, right? So RAVSim is offering you no need to worry about the code or anything. You can come here, you can just select the folders like industrial, and that's a class B. Here we go, and you can set how much percentage you want for the training and the testing for both classes, which output you required, and for example you need the JPG or whatever it is depend on your. So I put it bunch of because we don't know at the moment which the images are required and inside the folder. So right, but I need only a PNG output, so I can use the PNG. I can use the size for 64 by 64 and so on. It depends on you, right? So let's start. Once you're done with this, you can see the output. Let's wait a couple of seconds more. Here we go. So here you can see the total images of industrial was class A is 2500 and class B was 3000 and so on, right? And you can also visualize class images, how it looks like and so on, the output as well. Same for visualizing the class B, and that's all. Your data set is ready for the training. Now you know how to learn the parametric value, which is how the parametric value are dependent to each other and the balancing and so on. You created a data set. Now you need a training. So let's go here. So here you know we can select for example, we created this data set, right? Train, which is 80% for A and B. And this is the test. You can see inside as well. So this is the test folder. You give the path both for train and the testing images. You have already select those parametric values and so on. Once you are done, you can just start click. It will take approximately at the current setting 5 minutes, which increased as RAVSim v2.0, which was taking around 10 minutes approximate. So it's a 50% increment in the processing speeds. Of course, more larger data set required more execution time and so on. So it depends on, we are claiming with the 1000 number of neurons in a hidden layer. It will only take 5 minutes and approximate 5 minutes. So I will not go with to run the model because it will take some time. So I already generate the weights. And if you want to visualizing the weights, you can click here and you can select the number of percentage of the data you want to visualize. So I will go with the 25% of the data which we trained the model. So here it will take a couple of seconds and here we go. So here you have weights look like. So you can either zoom in and zoom out and whatever. This image also saved in your folder locations as well. So we can go back and so on. Once you are done with the training and you have a weights now, but you need to know about how the neural models, which neural model is good and so on the things, right? So that's what we said, a neural model comparisons at runtime. So in this VI, you have two options. Either you will go with the individual model comparisons or you can go with the all model comparisons. Let's start with the individual model comparisons. By clicking this button, you will see here. So you must need to select two different neural models first. So let's say LabVIEW and LabVIEW model. And you can select with the accuracy and the performance. Run comparison. And here we go. So these are the LabVIEW neural model parametric set of parametric values, and this is the LabVIEW parametric set of parametric value. You can start with the run comparison, and here we can go. LabVIEW accuracy was 72.55. It's a static data set, so that's why it's quite fast. But you can update the data set as well later. So this is the LabVIEW error was 0.2% and LabVIEW error rate was 0.34%, and you can also visualize in two different plots. You can go back or you can either update the value and you can generate again. You can see the reaction at runtime, right? And if you want to increase the timestamp, you can see the link that the error rate is quite decreased in both models. Here you can see a more clarity that LabVIEW is quite better if there is a timestamp is longer than the as compared to the LabVIEW neural model. So these kind of learning you can only learn at runtime. Either if you have to go to run the code again and everything, you can't focus on one specific problem. So that's why runtime simulator is quite important. As you saw that the LabVIEW produce better output as compared to the LabVIEW if you increase the time step, right? So these things are quite important for the developer as well. That's why we claim that RAVSim v2.0 is also very important for the developers. If they know about these things, it will be good for them to write, to design a better model and get a better results at the runtime applications. You can go with the continuous simulations back, and now If we will go with the previous one, you have to exit comparison from the individual one, and we will go with the all model comparisons. In all model comparisons, we are here. So here we have a leaf, nleaf, edx, hh, ifsa, kif, iz, srm, and theta neuron model. You can update anytime, any value. Once you are done, you can create a run comparison. And here we go. These are the accuracy of these all models, and these are the error rate of all models. You can see in both results. You can also increase and decrease the value and generate again. And now if you want to see our detailed results of the each model as compared to the performance loss of the other neural model. For example, this is the leaf neural model. It's the accuracy, and that's the error rate compared to the nleaf, compared to the edx, and so on. You can see the comparison of one individual model as compared to the all other neural models. You can also see all model performance loss. You can see the error rate as well. If you want to more focus, you can use the feature of zoom, which you can allow you can use a mouse to adjust the plot and so on. So by continuous simulation, you are back again. So you can go back again, and if you want to select the spiking activity of all neural model, so you are here to go with this VI. Here also we have all the neural models, and you can run comparison. As you can see, the data is completed. We can generate a plot. So here we are on the plots. You have all the plots and the sequences. Again, the zoom feature allow you to zoom it, and mouse you can control the plot, and you can go back. You can again increase and decrease and so on. Same for the computational complexity of the neural model. So these are the complexity of neural model. You can also again run comparison. It will give you the induction, and this is the output. Same you can generate again. So it's a random selection of the static data set, so that's why every time the result will be different. But if you are using the static data, your specified data set, it will be always same. So go back to the continuous simulation. You can also check the biological possibility of the each different neural models. So here we go. You can create a runtime, and as you can see, it is done. And for example, where we are increasing the number of neuron in a KIF neuron model, the results are quite different, right? So that's the learning procedure. You can go back. So the RAVSim is a standalone simulator that offers a runtime interactive environment for analyzing and designing SNN neural models, and also to learn which model is good for your specific task without worrying about understanding the lengthy code. And the most important, RAVSim is an open source simulator. And if you would like to join us, then please contact us. You can find our contact information. Go with the help menu bar. Here's the about RAVSim, and you can find our email addresses. You can contact us. You can write us if you got any problem, or if it is difficult for you to learn. We will make this better for everyone. So thank you for your time, and see you soon with more open source tool. Our aim is to make machine learning available for everyone, even though your background doesn't link with the computer science or you don't have a high skills in coding. But you can train the model without any line of the code. So it is the simulator with 0 line code. At a high level, you can produce your output. Once again, thank you for your time.